Well, now you have the whole weekend to study, also an extra day, so I guess I could have told you to memorize those stuff. Any other questions about expectations? At least half the test will be, can you take a derivative?
Do we need to have 3.1 prep done?
No.
Okay.
No, I changed that date to Wednesday already.
Gotcha.
That's the only date I've changed. I'm waiting on confirmation for other dates. But 3.1 you don't need to look at until after the test. There was, implicit curves and implicit derivatives, implicit differentiation. But then having a curve where you have y's mixed in, and then knowing how to work with that also. You know, like how to find the tangent line, the actual equation of the line. Any other questions about what to expect? I mean, the whole goal tomorrow is to take the test. And then Wednesday we'll start 3.1. We've been told we have to include true, false, and word problems on every test. And thankfully, we had a section of word problems. So I'm not throwing random ones at you. That's my workaround on some of those. Alright, so I was going to go over the quiz. I think I know which switch it is. It's been what, half the semester? Alright, so what's the derivative? So some of these you just have to memorize, right? So this is one, did you memorize these two? So the derivative of log base 3 would be, so the derivative of the logarithm is 1 over x, right? But then because it was base 3, you have to then divide by natural log of 3. Right. And then like for the derivative of 7 to the x, since it's exponential, it's its own derivative, but because I was base 7, not base e, you have to then multiply by natural log of 7. Alright, so these were, did you memorize these or not? Several people shook their head no. We have to memorize things. There's sadly no shortcut there. Alright, what about this one? What rules do I need? Yep, and what else? Chain rule for that 3x part. So what's the derivative of secant? Secant times tangent. So it's going to be, because I'm plugging in 3x, I have to do secant of x times tangent, or secant of 3x times tangent of 3x. I'm clearly tired. I just covered up the chain rule part with my hand. That does nothing. But then the chain rule says, because I had a 3x in here, I need to multiply by this. It's always easier when somebody just projects the answers. That's fine. Yeah, I'm not looking for major simplifications. This is still, did you use the right rule at the right time correctly? Alright, so then what's the derivative of x to negative 1? Bring down the negative 1, subtract 1. So I get negative x to the negative 2. You can leave it as x to negative 2, that is perfectly fine. On the test, or we had this on the last quiz, instead of writing that, I wrote this. And most people use things like the quotient rule. That's one you really, part of what we're checking is, do you know when to rewrite these to use other rules? Right. You don't always want to solve it the hardest way. Something like if I had natural log of x squared times x plus 3. What should I do first?
Separate it.
I could before taking a derivative, you would want to simplify this. So that's one of the things we're looking at, like break this apart as something like this. And then you can actually move this 2 out to here. So like use the log properties, make it nicer, and then take the derivative. Something like 1 over x, rewrite it as x to the negative 1, then take the derivative. So we're also checking, do you know, are you using decent strategy, or good strategies when taking derivatives. Instead of plowing through lots of chain and quotient and other rules that you don't necessarily need. If you do it that way, you do need it, but there's a better path to take. Okay. I changed this problem. So, but I didn't want to rewrite my key. So, what's the derivative here? What rule am I going to need? Chain rule? Yeah. So, what's the derivative of inverse tangent? 1 over
X squared plus
1 plus x squared. Yeah. What about the derivative of tangent? Secant squared. Alright. So I can take these separately. The derivative of inverse tangent is 1 over 1 plus my input squared. Remember, anywhere you always memorize it just for x. But anywhere you had an x, write parentheses and put the entire input. And then you multiply by the derivative of the inside. Same with this one, I'm plugging in 2x, so I put the 2x here, but then multiply by the derivative of the inside. Alright, so derivative of inverse tangent is this one formula, derivative of tangent is secant squared. And then you don't really even need to simplify that. I guess you need to say this is 4, this is 2. Alright, but then you don't actually have to expand this or do anything here. That part I wouldn't count off on, as long as you plug it in correctly to start. One thing I'm looking for is you don't want to do something like this. Because you have to square both the 4 and the x. So I am paying attention to parentheses when I grade this. Alright. Any questions on any of these? You haven't made flashcards? You had a whole weekend to make flashcards. No. Or you miss it on the quiz and then think, I should make flashcards or memorize these things before the test. That's the other reason we give quizzes. Alright. How do you find the derivative of x to the x plus 1? This was a more challenging problem.
on a log of what's happening in the differential.
Yeah. We actually have 2 ways we did this problem. One is, this is a good example for logarithmic. Why do I need something creative? Power rule says I have x to a constant power. Exponentials say I have a constant in the base and then x in the power. But here I have x both in the power and the base. I can't have both things happening and use any of the rules we talked about. So this is one where you have to do something like logarithmic. Or we have one other option. We could change the base. Typically I would think logarithmic on this, it's probably easier. They're equivalent to each other. So I wrote both of these solutions. If you do logarithmic, what do? First take the log of both sides, and then do implicit. So if you take the log of this, why would I take the log of this right hand side? Well, I took the log of both, but why would that help on the right hand side? What happens here? Yeah. The problem was I had x here and here. So now this moves out front. So now I no longer have x in the power and the base. So if I want to take the derivative of log of y is 1 over y dy dx. And then the derivative over here, what rule do I need? Product rule. I have this times this. So x plus 1, what's the derivative of natural log of x? 1 over x. And then derivative of x plus 1 times natural log. So get this. So what happens? I have, when I take the derivative of both sides, I get this. 1 over y dy dx on the left, and then based on the product rule, I get this on the right. What do I do next? My goal is to find dy dx, right? So I need to get dy dx by itself. I multiply both sides by y. And then the last thing is, it's kind of weird to have a y mixed into my formula. I can't just plug in, right? So So I go back to y is x to the x plus 1, so I just replace it back with x's. So now I have a derivative formula that only has x's. This is definitely not one of the other rules, right? Like I can't just use a power or exponential rule. I really have to solve this, taking everything into account. So this is one, do you realize when you look at this, you can't just do the straightforward thing. You have to be more creative. There's a reason we need logarithmic. This is a type of example where logarithmic makes a lot of sense. What else did we use logarithmic?
Just to simplify big derivatives
Yeah.
on natural log on one side.
Yeah, when I had things like this, and I don't want to do a bunch of product and quotient rules. If you take the log of both sides, now this side simplifies and makes all the derivatives easier. So we kind of had two times we need logarithmic. When did we use logarithmic? If you wanted to simplify instead of using a bunch of quotient and chain rules and product rules and everything else, like that one I just wrote, so something that just looks horrendous, something like logarithmic and break it apart. The other time we need it is when you have something like x's in the base and the power. Unless for this one you can technically do what's called a change of base. Instead of writing x to the x plus 1, do e the natural log of that value. That undoes it, right? E the natural log, these are inverses, so this would just be whatever's in the parentheses. I'm not actually changing anything, I'm just rewriting it. The reason you would do that, now this x plus 1 again moves over. So it's almost like what I had before. Before I took the log of both sides, if you did e to the natural log of this would be y and this would be this. I mean, it's almost a similar trick, which is why now when I take the derivative, here I get y prime directly, but now I have to take the derivative of this thing. So it's a slightly more involved derivative because I didn't do it using implicit. All right, but if you want to take the derivative of this, derivative, now it's an exponential, right? My base is e, and all the x's are in the exponent. So I don't have to worry about this mixing thing. I made it where my base is a constant. That means I'm allowed to use standard rules. And then I can go from there. Okay. This is one of those questions to see, are you really paying attention to these rules? It's also one that is a little bit harder, so it's good to have it on the quiz before we have it on the test. I'm not saying this will be on the test exactly, but I'll let you know something you need to always think about. Any other questions on this one? Alright, so the last one. I want to find a second derivative of this. How do you find second derivatives? Find the first derivative, then find the derivative of that. So if I want to find the derivative of sine of x squared plus 1, what's the derivative of sine? It's the cosine function. So I would get cosine of my input, but then by the chain rule I need to account for the input not being just x, so I need to multiply by the derivative inside. So what's my derivative? Derivative of this is 2x, so 2x times cosine x squared plus 1. Alright, so I get my first derivative. What changes for the second derivative? Yeah. If I want to take the derivative of this expression, I have this times this, right? So in the second derivative, I also need a product rule. So it's going to be 2x times the derivative of the second term plus derivative 2x times the second term. I have to do a product rule here. I didn't need it in the first derivative, but I definitely need it in the second derivative. And it's coming out because of that chain rule part. All right. So what's the derivative of cosine? Negative sine. So negative sine of the inside, and then chain rule multiplied by the derivative of the inside. Then derivative of 2x is 2. So then all that's left here after I take this one, derivative of x squared plus 1 is the 2x again. So I get this. A lot of what we're looking at is, are you using the right rules? So one, you have to memorize certain formulas. But then, are you using the right rules when you need them? And then the most advanced techniques are, do you know when there's a better way? So did you simplify the problem first before taking a really awful derivative? Or did you look at it and realize, I can't use standard rules, I need something like logarithmic? There are certain techniques we cover that are a little bit more advanced, but it's because sometimes you need them. And then we're testing, do you know when you need them? As far as finding derivatives though, some of these on the second page were about as bad as it gets, hopefully. On the test, so on the quiz, a lot of these were more memorization based on the front. Like you might need the chain rule, but it was really, did you memorize the formula? On the test, it's more likely to, like none of these had a product rule or quotient rule. On the test, there will be a product or quotient rule somewhere. All right, this one, the only product rule, you needed it on that page for these two. But on the test, I'd say finding the derivatives are going to be slightly more involved than these. These were a little bit more memorization still. All right, but again, that is most of the test. And then the other topics we covered, like word problems and tangent lines, limit definition. You understand the idea of this is slope, like visually, this is slope. So I do recommend going back to the old quizzes. So like on the first one, it was, do you understand the notation and how to interpret slope? When are you not differentiable? When you have things like corners or cusp or discontinuity. So something like this, you don't have a derivative at the corner. Other one, make sure you go back through and know what the limit definition is. There will be one of these problems, guaranteed. That is like all of 2-2, so we have to include it. And then going back to quiz 2. Quiz 2 is, or well, technically quiz 4, was a lot of this same find the derivative, right? So this is the one we kind of talked about another time. You'd want to write that as this. Instead of using a quotient rule, which I am impressed if you get the quotient rule correct. Like I'm glad you memorized that and used it when it was a quotient. But the more advanced thing is, do you know the best way to solve this? And really on a timed exam, you want to do it the better way instead of wasting more time doing something that's more work. All right. But yeah, definitely go back and look at this. This had more of the rules. The related rates problem will be something like a circle, square, box, right triangle, similar triangle. It won't be a cone. I decided not to use a cone. So it'll be one of the more standard ones. But, and by standard, I mean the formula is going to be one of the more standard formulas. So Pythagorean theorem, similar triangles, area, volume, stuff like that. I think in the homework we had a cone, so this one I wasn't going to do that since that one's always a little bit more involved. For cones, you always need similar triangles and the volume formula, so it ends up being more work. On a 50-minute test, that's too much. All right, and we're out of time. So remember, you don't have anything else to do tomorrow.